So write heading, right? Reflecting telescope. So the telescope with mirror objectives. The telescope with mirror objective with mirror objectives or objective is called reflecting telescope. You can see the picture left hand side, reflecting telescope. Right heading. Now here write schematic diagram. Okay, schematic diagram. Whatever picture is there given there, you do that. Schematic diagram of a reflecting telescope. Of a reflecting telescope. This telescope other name also there. Cassegrain. Okay, Cassegrain telescope. So here picture is there. This picture you do, please everyone. Left side picture you can see. So this picture you do. Mirror objective, secondary mirror, eyepiece. So do this one. So you can draw like this. Yes. So this is a reflecting telescope. Reflecting telescope. Diagram should be done like this. Objective mirror. Objective mirror is primary, that is concave mirror. This is secondary mirror, that is convex mirror. And you have eyepiece. Here you have eyepiece. So all the things you can check here. So schematic diagram of a reflecting telescope you write. Advantages. Why we are taking this one? This telescopes. So write advantages. Write advantages of reflecting telescope. Reflecting telescope over refracting telescope. Or directly write advantage reflecting telescope. Now you can understand everything here. Okay. Now number 1 point, write I point. Right? Mirrors. What man asked first point? Mirrors can have larger size than lenses. Right? Mirrors can have large size than lenses. Mirrors can have large size than lenses. Next is say mirrors don't cause chromatic aberration. So write down that. Right. Mirrors don't cause chromatic. Chroma means color. Chroma word comes in a color. Chromatic aberration. Mirrors don't cause chromatic aberration. Now third point, right? Next ma. If parabolic mirrors are used, if parabolic mirrors are used, then what will happen, say? Then spherical aberration will be minimized, will be removed also, you can write. Okay, is removed. If parabolic mirrors are used, then spherical aberration will be removed. So 5 point is there. Now fourth point, right? Mirrors can have large size than lenses. Mirrors don't cause chromatic aberration. If parabolic mirrors are used, then spherical aberration will be removed. Next, mirrors are lightweight as compared to lenses. Next, another point, right? Mirrors are lightweight as compared to lenses. Full stop. Now fifth point I'll write. Fifth point you would write. Complete up to this one. Mirrors are easy to mount. Where tell? Easy to mount on the edges. Fifth point. This is fifth point. Mirrors are easy to mount on the edges. So this much point to remember. Fifth point, advantages of telescope. 3 mark question they will ask advantages of telescope. Any 3 point you can write. Okay. Book also some idea is given here about the telescope, why it is used. That also you can check over. Okay. Here you can check once. You can understand these lines. Okay. Or all 5 points I have given to you. Okay. Here you check all of you. See one Cassegrain telescope. It has a large focal length in a short telescope, and the largest telescope in India is in Kavalur, Tamil Nadu. Where it is? Kavalur, Tamil Nadu. It is a 2.34 meter diameter reflecting telescope. Okay. So where it is there? Kavalur we have. And about astronomical objects, if you want to know more now, actually we have Indian Institute of Astrophysics, Bangalore. There you can learn. Okay, it was ground, polished and set up and is being used by the Indian Institute of Astrophysics, Bangalore. Okay, so largest, tell you, understand everyone, the largest telescope in India, where it is present? Kavalur, Tamil Nadu. Okay, so HM sir will take you one day there. Okay, so everyone go with HM sir once and visit that Kavalur. Clear? Write some important ones. Number I or number 1, right? Number 1. Right, cutting of lens. Cutting of lens. Cutting of lens. Now number I. Cutting of a lens. Now cutting perpendicular to, or first write cutting parallel to principal axis. Parallel to principal axis. Principal axis. Like this, some points will be there. How much point I can write? I'll write. Today some photo I'll send. Can you write yourself? Some 6 to 7 points. How much point I can write? I'll write. Cutting parallel to principal axis. So now lens you see here. Now you are cutting like this. So after cutting what happened you say? After cutting what happened you say? Lens became like this. Lens became like this. Yes or no? Clear? If you cut lens, lens will become like this. Suppose initial focal length f, initial power is p. Here also focal length f. Here also focal length f. Power is p. Power is p. Are you getting or not? Yes, sir. Sir. Cutting lens. Cutting lens perpendicular to principal axis. principal axis. Now how you are cutting? You are cutting like this. Okay, this is your F, this is your P. Now this is after cutting. After cutting, what will do? Length will become like this. Length will become like this. Now this will become 2F and the power will become P by 2. Remember, P means power. Power will become P by 2. This is also 2F. Power becomes P by 2. You write how it is coming, we can explain. P for what? Power. F for focal length. That idea should be clear. Okay, P for power, F for focal length. Okay. Now second point. Cutting parallel to principal axis, cutting perpendicular to principal axis, both the things you remember. Okay, now second point, right? Number 2. Splitting of white light by lens. Splitting of white light by lens. So red and violet, how they are splitting, you try to check. Red focal length will be more than violet focal length, as wavelength is more, and wavelength and focal length are directly proportional. Yes or no? So remember this one, so you write this. So that means if white light is going now, then here this focus for violet, this focus for violet light, this focus for red light, FR, FB, FR. Okay, from optic center, FR, FB you are writing. Yes or no? I hope you are getting the point. Now number 3 point, you have two lenses. Position of two lenses. One lens position is a displacement actually X. Here one wall is there. Okay, what you have? Two opposite wall. Two mirror like you can tell also. One object is there, your wall is there, opposite walls. One object is here, one object. And here you have two positions of image. Two positions of image. And this distance is D. Okay. See, this is your one lens only, this is the displacement. Your focal length is F. For one position you are getting one I1, and for another position you are getting another image. Okay, another position you are getting. So now if I write focal length, what is the focal length? It will be, focal length formula will be, what ma? D square minus X square by 4D. D square minus X square by 4D. This formula directly you remember, you can prove this also, no worries. But directly you can remember. Okay. D square minus X square by 4D. So write this focal length. This is the focal length of, this is the displacement, X is displacement. X is displacement of lens. Okay. And D is a distance between two walls. One is object I, another is I also. You can write knowledge, two positions of image. Okay. And F is focal length. F is focal length. Yes, Semi? Go to computer class. So, this one you remember. And another point, fourth point, right? Fourth point. Right, F equal to x1 into x2 root. This is called Newton's formula. I will explain in the next class. Right here. This is Newton's formula. Newton's formula. I will explain what is this. Okay. If a lens is there, here you have an image, your F1 focus, your F2 focus. Here you have an object. Suppose here you have image. Here to here it is x2. And here to here it is x1. Okay, this is F1, this is F2. Okay. Ray diagram you can complete, no risk. Ray diagram you can complete. Okay. So here focal length of lens is nothing but root under x1 into x2. This is called Newton's formula. Up to this one you remember. Next class other thing will study. Okay. Thank you all of you.